Hey there, welcome back. This is where we stopped last time. We formulated the problem like this. We had this vector. This is the vector which we called previously P for blood pressure. And it equals A, some number, times another vector W, which is the vector of weights. And our task in linear regression is to find this number A. So let's see how this is done. Now remember I told you I'm going to skip all the mathematics, so I'm just going to jump to the end, the formula for A, how we get it. This is the formula, and it might look like gibberish for now, but I'm going to explain everything in a second. So right now I need to explain three things, okay? What's this WT, right? We know what W is, but we don't know what WT is. How do we multiply vectors? We have a multiplication of vectors here and here. We need to explain what it is, or at least how it is carried out by your computer. And we have this inverse, right? This parenthesis at the power of -1. It's called an inverse. We need to explain what it is. So in order to explain these three things, I'm going to make a small digression to talk about vectors. It would really be a small digression, so bear with me. So a vector is just a list of numbers, right? Here we have two vectors. Both of them are length 5 vectors. And you can see that they're arranged as a column, okay? These are column vectors, okay? So if this was W, a column vector, WT is called the transpose of W. It's just the corresponding row vector. Notice these are the same list of numbers. This is just a column, and WT is a row. Now, if we want to multiply vectors, they have to have the same length, okay? So WT times W, you can do it because this is a row vector of length 5, and this is a column vector of length 5. Notice also that the order matters. So let's write it like this. WT times W is not equal to W times WT, okay? This is very important. When you multiply, make sure you do this one, okay? WT times W, just as we wrote it down. Now, when we multiply a row vector by a column vector in the right order, we just get a number, okay? So WT times W is a number, so the inverse is just the inverse of a number, like the inverse of 3 is a third, okay? So this is easy. Now let's look back at the formula. So now we know what everything is, right? This is a number, this is the inverse of a number, and we know that we can multiply everything here because also WT is a row vector of length 5 and P was a column vector of length 5. Now let's go and do it all live in Matlab, and you'll see that it's really easy and that it really works. Alright, so we're in the Matlab demo, and we're going to see how we're going to calculate A. So I already put here the vectors P, okay? This is the vector P, which is the same list of numbers as we had in the presentation, and W, okay? And now A, as we can clearly see on the left, is this function, is this formula, okay? Inverse of WT, instead of T in Matlab you just write an apostrophe, it takes the transpose of a column vector, turns it into a row vector. So the inverse of WT times W times WT times P. This is A. We can see that A is a number, and it's this number. Now let's see if it works. Let's first plot W against P, okay? We can see we have 5 numbers, right? 5 dots here. We can roughly see that the row should, a line should go around here, okay? Let's see if it works, okay? Now I'll just plot, instead of P, I will plot W against A times W, where A is this A, okay? Let's see if it works. Lo and behold, it works beautifully, okay? So this is actually the line that we would expect to see. Now, given some other value of W, for example, 75, I can go here and find the corresponding level value of P without having to measure it. So we're pretty much done, and you might think you know all you need to know about linear regression, but you need to know a little bit more in order to go quantum. So we'll do that later.